And Your Excellency, ladies and gentlemen, Salam Alaikum. Thank you for having me here. I'm Shirley with SenseTime. First, I'd like to congratulate the opening of Global AI Summit. Thanks Audi Data and AI Authority for organizing such a wonderful global event. It's such an honor to be here. And today, I'd like to share something about recent progress on AI innovation and how we call machines thought experiment will make people's life better. As we all know, we've got paradigms in terms of scientific research. We have theoretical science, which involves deduction reasoning, and now with the supercomputer to do the theoretical deduction, we call it computer simulation science. Likewise, when we think experimental science, which mainly based on induction, thanks again to the computer, which enables us to draw more insights from the given data. Here's how we got the big data science, or the data-intensive science. Some people may argue that simulation and big data both mark the new paradigms of innovation, but I think they are more like the computer version of induction and deduction. On the other hand, however, only few of the groundbreaking progress in human history is actually marked by those paradigms. It is what we call the thought experiments, the incredible speculation and random guess of genius that lead most disruptive innovations that have been tremendously changing our life. So when we are talking about what we've got today with recent development of AI, we can again ask the question that Alan Turing asked in 1950, can machines think? And our proposition is a bit simpler. Can machines have its own thought experiments? Or can machine guess? I think the answer is yes for sure. As in some areas, machines have set us models in applications beyond our expectation, and even in some degrees, force us to adapt ourselves into them. We've been talking about big data all the time and how we can make the best out of it. It's probably not wrong, but as we face more complex problems, the data-intensive approach is no longer the only option. Let's take a look on the Go game. The game that contains so many possibilities that even we could use the same number of supercomputers as atomic particles in the known universe combined and keep them running since the Big Bang. We still could not figure out the best solution of it. Then we've got AlphaZero, which is driven by close to zero data, but capable of forming its own understanding of the game and discover its own moves to beat all human beings. What's the takeaway? Did AlphaZero give the correct solution to the game? Probably not, but it doesn't prevent it to be the strongest Go player on the planet. So what are the necessary conditions for machines to have its thought experiments advance in technology development? I believe it is the AI computing power. Actually, the demand for the computing power by the top-tier AI algorithms has increased by nearly 1 million times in last decade. That's why I like to say the universal AI infrastructures would be the fundamental elements to drive the innovation paradigm shift. And at SenseTime, we have AIDC in Shanghai and designed for facilitating machine to conduct its own thought experiments. With a 4.9 exaflops total computing capacity, the facility can process 23,000 years-long video footage in one day. We also have built a mini AIDC in Saudi Arabia together with our partner to facilitate digital transformation to local cities. Also, because of their nature of being guessed out, there are all uncertainties involved. But it doesn't mean they couldn't be useful. Take the invention of airplane as an example. Even today, physicians could not explain well how it could possible that the heavier than air object takes itself off the ground. But we all take flight to travel. That's how industrial applications validates the thought experiments. With all unpredictables, instead of saying no, we should embrace the outcome and put them into industrial context to define the boundary of applications. That's how we take the full advantage of the machine's thought experiments. Here are some examples. A small scenario in autonomous driving, the automatic parking. Most experienced drivers could summarize the rules of thumb on parking to teach newbie. But those things cannot be simply transferred to the computer program. Instead, the computer is learning by itself and somehow develop its own understanding on the parking skill. Until now, scientists have no way to explain the logic why computer could figure out those turns, reverses involved in the process. But they do not prevent all kinds of automatic parking systems have been developed to and deployed to millions of cars that we use every day. Another more complex case, the decision-making in open-ended environment, where humans often struggle to find the best solution in. For example, our transportation. We had a selected area in Shanghai where we can test the outcome of AI's thought experiment, and we are surprised to see, with the intelligent transportation system powered by AI, that the average waiting time for local traffic lights reduced by nearly 20 minutes. Moreover, there are other cases such as smart city or smart communities that we may believe they are big data driven. But when we take a closer look, they are far beyond the big data. We are solving what we call the long tail, low frequency events, the incidents like fire in the store, that we only have very limited data, if any, to analyze. For those cases, we can only rely on machine to develop its own insights on those issues. We don't have to understand each and every step of the process, but still, we could use them for more efficacy governance. And today, I believe that the new development of AI is just like an apple that fell on Newton's head. And we look forward to partnering with you to push the boundaries of AI innovation and create a better future through the machine's thought experiments. Congratulations again to Saudi Data and AI Authority, and I sincerely wish the Global AI Summit a great success. Thank you.